So in a previous video, I talked about how to graph the sine function, and I did it step by step. I produced 3 different graphs in order to get to the final answer. And I think that from the student perspective, it's like, that's great, but I have a test to take and I have to do this in a timed environment. Isn't there a faster way to do this so that I don't have to do 3 problems every time I do a problem? And of course the answer is yes. So let's go ahead and do what I would call like the quick version of graphing these. I think it's good to understand how to do it the previous way because you're understanding what each component does for you. But let's see, how would I personally, having done this many times, approach graphing this function, 5 sine of the 1/2 x plus pi over 3. So what I will do is the first thing is that I need to force my function to look the same as the generic function. And in this instance, what that means is here, if you look at the generic function, I have the x minus d, that is inside its own quantity here, inside its own parentheses. So I need to factor out the b value, which for me, the b value is 1/2. I need to factor that out in order to force my function to look the same as the generic function. So I will do that now. I'll have f of x equals 5 sine. I'm going to bring this 1/2 out in front, so I'm factoring it out. So it's not in the x anymore, and then I divide pi over 3 by 2, or sorry, not by 2, by 1/2. So when I divide by 1/2, that's the same as multiplying by 2. So I end up with 2 pi over 3. So that is kind of forcing it to look the same as the other function. And then I will go through each component and see what is it adding to my problem. So I'll do them in alphabetical order. We'll start with A. So A for me, oh, sorry. I underlined the wrong thing. A for me over here is what's in front of the sine. So A equals 5. This is the amplitude. So that is how tall my wave is going to be. I'll look at B. B gives me, here in this instance, B is 1/2. And this gives me the alteration to the period of the function. So I'll do a little more work with this. B is 1/2. The period of sine is 2 pi. So the new period is 2 pi divided by 1/2. Again, when I divide by 2, that's the same as, or divide by 1/2, that's the same as multiplying by 2. So the new period is 4 pi. C, my function does not have C. I have no plus anything outside of my sine function. So C for me is 0. This is the vertical shift. So that means that I have no shift up or down. My function, my new sine function here, it is going to be kind of centered around the x-axis. And then D, for me, D is 2 pi over 3. And 2 pi over 3 is my phase shift, also the vertical shift, or sorry, horizontal shift. So what I'm looking at here is I'm saying, okay, I know what each of these components do. I have a different period I need to handle. I have a different amplitude, and I have this horizontal shift. I always deal with a horizontal and a vertical shift first. So I have no vertical shift, but I will handle this horizontal shift. So let's go ahead and sketch out my axis here. So let me draw over here. In case you're not familiar, we should always consider what the standard sine function looks like. So the standard sine function, it crosses, it hits the y-axis at the 0 here, so it does touch the origin. And then we go up, down, and this is what the basic sine function looks like. So what I need to do is I need to handle my phase shift, my horizontal shift. Because this number is positive, I have a plus there, I'm going to shift it to the left. It's always opposite what you think. So what that means is, what I like to do here is I like to put a whole bunch of points in that are relevant and then draw my graph last. So the very last thing I do is put in the actual wave. first thing I do is draw all these individual points that are important matters for us. So the first thing I'll do here is I'll say, okay, I'm going to shift this to the left. So instead of hitting at the origin, I'm going to shift it. I'm hitting somewhere to the left of the origin. How much left? Well, 2 pi, or 2 pi over 3. So this point, this value, is 2 pi over 3. Now I need to see where else is it going to touch the x-axis. So if I look at my original function, it touches the x-axis at 0, at 2 pi, at pi, right? I have a different period though. So I know that I'm going to hit the x-axis 4 pi to the right. So I'm going to add 4 pi to my negative 2 pi over 3. So negative 2 pi over 3 plus 4 pi. I need the same denominator to add these. So I'll do that as negative 2 pi over 3 plus 4 times 3 of 12 pi over 3. So that's 10 pi over 3. So somewhere over here, 10 pi over 3. And this corresponds to my 2 pi location. So these are corresponding locations. And then I know I'm going to hit halfway in between the two. So my function looks something like this. So I have here, I know where, I have 2 points that my function is touching the x-axis. I know that the amplitude is 5, so I'm going to draw my lines here, and I'm going to call this negative 5, and I'm going to call this positive 5. I have indicated my new period as being 4 pi. I have a couple labels of where my function is touching the x-axis, and I'm all done. So that is how you do what I would say is kind of a fast version. First, you address the phase shift, draw a couple of points that indicate, so draw where your new, point that you cross the axis is. So I shifted it to the left by 2 pi over 3. Then add 1 period to that to get where your full cycle will end. About halfway between that is where your half cycle is, and then you put in your amplitudes. So that is how I would handle the fast version of graphing the sine function.